All right, so I forgot to record the beginning, so just to recap, we're talking about method 1 for multiplying fractions, where you multiply the numerators, which is the tops, multiply denominators, which is the bottoms, and then simplify if possible. And we've done the first couple of examples. 4 times 1 is 4, 7 times 8 is 28, and then we reduce the fraction to get 1/7. 7/8 times 2/3, we got 14 24ths, just multiplying across, divided by 2 to get 7/12. All right, so we're ready for example 3. So I just multiply across. So 1 times 2 is 2, 10 times 3 is 30. Can I simplify that? Yes. What would I divide by? 2. They're both even numbers. If they're both even, you can always start with 2. I get 1/15, and that one's actually done. It can't go any further. So that's not so bad so far. Now, if we get down to example 4, the numbers are a little bit bigger. 3 times 8, what is 3 times 8? 24. What's 4 times 9? 36. And then what would I divide those by?
12.
We could divide by 12. You could start with 2 and then 3 and do a bunch of stuff. They will both divide by 12 if you're thinking about that. And then we get 2/3. How many people think that that's like remembering to divide by 12 is kind of tough, and you would have divided by 2 and divided by 2 and divided by 3. It's totally fine to do that in steps. You can see these numbers are a little bigger. They're just a little bit tougher. Now, what do we do if we have a whole number like 28? How do I make that a fraction? Go ahead.
Put it over 1.
Put it over 1. So I'm going to rewrite this as 3/7 times 28 over 1. So I want to change it to a fraction, and that's how we do that. So if I multiply across, 3 times 28, that's not on my times tables. What is it?
84.
It is 84. So I might have to do some long multiplication out to the side if I wasn't allowed to use a calculator. That's a little bit hard. And then 7 times 1 is not so bad, that's 7. But then I have to think about, oh gosh, 84. Okay, it actually does divide by 7 if I can remember my times table is up that high. And I get 12 over 1. And 12 over 1 just reduces to whole number 12. So if you get that over 1, you could leave it like that, but we usually just go ahead and write it. Yes?
Can you leave it right here? I forgot to do example 1. Well,
Okay.
I did example 1.
So I won't take it off the screen, but I am going to move on. All right, so on example 6, I have 30. I'm going to change it to a fraction, so I'm going to put it over 1. And then I have 4/5. So I'm going to have to take 30 times 4. It is 120. And then I have 5. And then I know that these both will divide by 5 because that ends in a 0, and that's 5. So I can divide by 5 and divide by 5. And I might, if I don't get to use a calculator, and I'm not good at mental math, I might have to actually do long division to figure out 120 divided by 5. I'm going to just go ahead and give you that it's 24 and 1. But what I want to show you with these last couple of examples is using this method, there's a lot of reducing that has to happen on the end. And you might be reducing some pretty big numbers. Numbers, you might have to do long division. On the test for this, you're not going to have a calculator, so this may not be the way you want to go. Okay? Method 2 eliminates reducing big numbers on the end. We do a lot of reducing on the front. Okay? So I'm going to show you a trick. Okay, did you get it? Yes? Okay. So we're going to go up to method 2. You can get it at the end. Okay, so step by step. The first step is we're going to simplify any numerator, any top, with any denominator bottom. So they don't have to be in the same fraction, just any top with any bottom. We're going to reduce it. Then we're going to multiply numerators, which is the tops, and then multiply the denominators, which is the bottoms. So I'm just having you like fill in to remember which part's the tops and the bottoms. So I'm going to do a quick example that's not on here. So I'm going to put a little sticky note here for just a second, and you can just watch this. Okay? If I have 3/4 and 2/3, 3/4 does not reduce and 2/3 does not reduce. If I multiplied this, I would get 6/12, and then I'd have to reduce it down to 1/2. Okay? What if I suddenly switched the numerators
No way!
and made it 2/4 and 3/3?
No way!
How? That's impossible.
Okay, so if I was just multiplying these, I'd still get 6/12, right? It wouldn't change anything. But what changes is if I were to switch those numerators, I could suddenly reduce these before I multiplied, and I'd have 1/2 times 1, which is 1/2. So what I'm going to show you today, it is basically a method that is based off of, I could, in theory, switch these. We're not actually going to rewrite it to switch it, though. We're just going to simplify any top with any bottom, and we're not actually going to physically write down the switch. So what I mean is, do you see how there's a 4 here and a 4 over there? I could switch these and rewrite it, but I know writing more steps just gets laborious. You can reduce any top with any bottom. So I can reduce this 4 with this 4. 4 divided by 4 is 1. And this 4 divided by 4 is 1. You have to divide them both by the same number, just like reducing normal fractions. And then I multiply afterwards. So I have 1 times 1 on the top, which is 1. 7 times 1 on the bottom, which is 7. And I didn't have to do this with 28 and remember all of those.
That's insane.
Okay, we did this last year. You weren't in my class last year, though, were you?
No.
Suddenly I thought you were a 7th grader for just a moment. I don't know why. It's in there. Okay, so let's look at this one.
More days.
So can 7 reduce with either of these bottoms? No. What about 2? Can 2 reduce with either of these on the bottom?
Yeah.
Yes, 2 and 8 are both even. So I'm going to take 2 and divide by 2. What'll that give me?
1.
And I'm going to take 8 and divide by 2
4.
and get 4. And then there's nothing else I can do on the front end. Hey guys, I shouldn't be seeing any fidgets. They're put away. You have a pencil in your hand. Okay, so we have 7 times 1 is 7, and then 4 times 3 is 12. And look, we're getting the same answer that we did over here. But I was able to reduce 2 and 8 instead of having to do 14 and 24. It just makes the numbers smaller. You reduce it before you multiply, and then if you do all of it up front, you don't have to worry about simplifying your answer. And you get to work with a lot smaller numbers, which for those of us that struggle with multiplication facts is going to make it a heck of a lot easier. Okay?
I don't understand.
So let's look. You don't understand?
How this works.
It's because I'm mentally switching around and making it 2/8 and 7/3, and we're basically just reducing the 2/8 and making it 1/4. I'm just not actually switching them around to start with. Because when you multiply, I would still get 14 and 24 like I did over here. It doesn't change the answer. Because when you multiply, you can multiply in any order.
But what if you switch it and it doesn't make it to where you can reduce it easier?
Then you don't do it.
Okay.
If there's nothing to reduce, then you just go back to method 1 and you just multiply. Okay? So he's asking, like, what if nothing over here crossed off? If nothing over here crossed off, that means you can just multiply through, and that means nothing will reduce. And it's okay. All right, so let's go down to this one. So 1 is not going to reduce with anything down here. Will 2 reduce with anything down here? Yes. Did you want to answer? Yes.
10.
Okay, so the 10 and the 2. So I can divide both of those by 2. So 2 divided by 2 is 1. 10 divided by 2 is 5. Good. And then we can multiply what's left. 1 times 1 is 1. 5 times 3 is 15. It works and it's beautiful. Like when I learned this in middle school, and I thought my math teacher was the coolest because we had been doing it this way in my 6th grade class, which was elementary in the school that I was in. And when I went to junior high, 7th grade, we learned this. And I was like, whoa, why didn't we learn this last year? Because it's so much better. I like it. All right, so on the next one,
Math teacher.
3 will reduce with the 9, right? So I'm dividing 3 by 3. What will I get? 1. And then I have to also take 9 and divide by 3, which makes it how much? 3. So the trick is you have to remember to divide both of these by the same number. So it's like you're reducing 3/9 to 1/3. We're just sort of doing it crosswise this way. Okay, and then the 8 and the 4 will also reduce. So what can I divide both of those by?
Double reduce.
Okay, you could divide both of them by 4, or you could do 2 and then 2 again if you like that. So I can divide 8 by 4 and get 2. Divide 4 by 4 and get 1. So I'm really just reducing 8/4 to 2/1. But now I've got really easy multiplication. 1 times 2 is 2, and 1 times 3 is 3.
Oh my god.
All right, so tell me again, what do we do with the whole numbers?
Oh, put them over 0.
Over, not 0,
One.
over 1. Good. So we take the whole number, we make a fraction by putting it over 1. And then I'm going to look. Does 3 reduce with either 7 or 1? No. Then I go to 28. Does 28 reduce with 7 or 1?
7.
Yes, it reduces with 7. How many times does 7 go into 28?
4 times.
4 times. So if I take 28 divided by 7, I get 4. If I take 7 divided by 7, I get 1. And then I have easy multiplication. 3 times 4 is 12. 1 times 1 is 1. And I could just write that as just a regular old 12. So think about 3 times 28. We were over here. We had to come up with 84, and we talked about how that could be hard if we're trying to do that in our head, or we might have to do long multiplication, because it's not a fact that we're just going to know. This makes it so we just eliminate all of that. The numbers are smaller. They're easier to use. There's a problem-solving strategy called solve a simpler problem. Anytime you can take a big problem, turn it into something smaller, it just makes everything easier. All right, so then this 30, we make it a fraction by putting it over 1. We're going to take it times 4/5. All right, so raise your hand if you can tell me what we're going to do with this on the front end.
Oh,
Jaden, what do you think?
reduce 30 and 5.
Reduce 30 and 5. So what am I dividing by?
6.
No, because 5 doesn't divide by, so divide by 5. Good.
5.
I kind of tripped you up there. It's okay. So I'm taking this and dividing by 5 to get 1. I'm taking 30 divided by 5 and get 6. So you just want to keep track of the fact that both of these are getting divided by 5. Some people have to actually write divide by 5 next to both of these. If you do, then that's fine. Okay, so then I just have to take 6 times 4, which is 24. 1 times 1, which is 1. And we get 24. They don't always come out whole numbers, but sometimes they do. And anything that you can reduce on the front end is just good. Okay, so at the bottom, there's what?
If you have like a fraction times a fraction times a fraction,
Uh-huh.
do you still do this?
Yes. Yes, you can use this. If you have a fraction times a fraction times a fraction times a fraction times a fraction, any top can cancel any bottom. And we use that in high school algebra all the time, because it makes a big algebra problem into a smaller algebra problem, and we can cancel stuff out. And then sometimes you don't even have to multiply anything in my algebra in high school. So it's a really cool thing to know now, because this is a skill that we just build on until you graduate, and it makes everything simpler. So this is sort of helping you think ahead. All right, so this part down here we're going to do quickly. It's just sort of visualizing multiplying fractions, and I'm sure you guys all saw this in elementary. 7th graders saw this with me last year, but I just think it's important so that we understand like multiplying fractions, what it means visually. I also want to put something out to the side with each of these problems to give you some clues for story problems. I didn't fit story problems into the notes for today, but there's one main type of story problem that you will see for multiplying fractions. If I see 1/3 times 1/2, in a story problem, what that's going to say, it's going to say 1/3 of 1/2. Like, we could think of a story problem. I have 1/3 of the half a cake that I had left over last night, left over today. So 1/3 of a half, well, what does that look like? Well, so if I'm doing 1/3 of a half, let's think about a half. Let's divide it in half this way and shade in 1/2. Okay? And then if I'm doing 1/3 of that, I've got to divide this into thirds this way. And you could think of this, sometimes they do this in 2 colors. This is 1/3 this way. And what we're trying to see is where the 1/3 and the 1/2 overlap. And so this becomes our answer. Okay? This is just to help you understand why the answer to a fraction actually comes out smaller to fraction multiplication than we're starting. If I take 1/3 times 1/2, is there anything there that cancels? No. So we just multiply straight across. 1 times 1 is 1, 3 times 2 is 6. And you can see visually why that is 1/6. 1/6 is smaller than 1/3, and it's smaller than 1/2, but that's what we get when we take 1/3 of a half. So if you ever get to a story problem where they're giving you fractions where it says you have 1/3 of 1/2 of something, that means you're going to multiply, okay? So let's do this one really quick. 3/4 and 1/3. So let's do 3/4 really quick. Let's divide 3/4 this way. I'm going to divide it in half and then fourths because that gets me somewhat evenly divided. And I'm going to shade those this way. I'm going to shade those horizontally. Okay? And then if I want to do 1/3, I've got to do thirds the other way. So I'm going to draw 2 lines in the middle to divide it into thirds. And I'm doing 1/3. So I'm going to shade that this way. So the answer, this is basically 3/4 of a third. So if I saw 3/4 of a third in a story problem, I would multiply. And you can kind of see visually that this, where they overlap, would be these 3 little boxes right here. So I'll color that in darker.
Yeah.
I'm out of different colored highlighters, or we'd use different colors, but we'll just do this with the cross-hatching. It'll be fine. So I'm ending up with 3 spaces out of how many total boxes did we make? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we end up with 3/12, which is what I would get if I just multiplied across this way. But that's not reduced. What would that reduce to?
Well,
What is 3/12 reduced to?
1/6.
1/4. So you have to kind of think about taking these 3 boxes and putting them this way. If I had 3 boxes shaded this way, that would be 1/4. But the main reason I added this to the notes the last couple of years was just to illustrate that your answer, when we're multiplying fractions, actually comes out smaller than either of the 2 original fractions, because we're doing a fraction of a fraction. And fractions are really just division. We're dividing this up a whole bunch. Okay? Yeah, I don't know if we're going to get through all of this today. I had grand plans. We'll just see. We'll see what we get done. All right, so over here we have 1/4 times 8. So this would be 1/4 of 8. So see I have 8 big squares here? We're going to do 1/4 of each of those. So I'm going to do 1/4 of this one, 1/4 of this one, 1/4 of this one, 1/4 of this one, 1/4 of this
Can you
one,
just fill in 2 whole boxes?
and just do 1/4 of the whole thing. You could. There's 2 different ways you could do this graphically.
Step 2 is the answer.
So then if I take all these little boxes, it takes 4 of these little ones to make a big one. So this would make a whole box, and then this would make a whole box. And so we would end up with 2 whole boxes when we're done. So what he's thinking is just if I take 1/4 of the whole thing, that would be 2 whole boxes, and that would be another way to visualize this.
Easy.
So there's more than one way to do this. And then if I were to do this by hand and make this 8/1, I would have 8/4, which also reduces to 2. I'm kind of running out of room there. But I just want you to visualize. We're taking a fraction of a number. When we take a fraction of a number, it's like dividing. It makes it smaller. I'm going to keep saying it will eventually get it down. Okay, so we're going to have 5 times 2/5. So if I'm doing this, there's different ways that we could do it. The way that I did it last year, I'm just going to stick with it, is I'm going to color 2/5 of each of the 5 circles.
Oh no, Mr. Bill.
Okay? And you don't have to color them perfectly. I was not always an impatient colorer. My kindergarten teacher was very exasperated with me because I didn't like to color everything in completely and take my time. I was more of a fast scribble and go.
I didn't like coloring in the lines, so
I didn't either. One of my friends wouldn't let me color in her coloring books because I did not stay within the lines. We had fights about it in elementary. It was great. We're still friends. It's fine. All right, so how many whole circles could I make with these?
Oh.
So it takes 1, 2, 3, 4, 5 to make a whole one. What do you think? 2. So 1, 2, 3, 4, 5 would make a whole one, and then 1, 2, 3, 4, 5 would make another one. So the answer to this is also 2 whole circles. If I made this over 1, you would get 10/5, which is 2. Or you could cross out the 5s and you would just get 2/1, which is 2. So it's just kind of a way to visualize what's happening with the fractions. And so down here at the bottom, it's just what I've been saying all the way through. Multiplying by a proper fraction, that means a fraction that's less than 1, makes the number smaller. It just makes things smaller, that's the main point of what I want to see.
Wait, stand there.
I'm gonna laugh if that's stuck in
Okay, shh. Guys, let's not have side conversations right now. Thanks. Okay, so I'm looking at the time and I think I'm going to just stop there.